Good evening. This is a re-recording of what we did in class today. Unfortunately, the class was not recorded as it should have been. I'm not sure just why. I'm not in the classroom, so I won't have the projector to shine on the board and then interact with the board. So we'll go straight to the item on my screen, and you won't see me at all, but I'll be talking through the problems that we went over this morning. Okay, on problem number 14, we're supposed to find the X and Y intercepts. The easy way to do this is just simply, replace the, if we want to do the X-intercept, we replace Y with 0. If we want to find the Y-intercept, we replace X with 0. If you remember, f of X is equal to Y, so we're going to replace f of X with 0. So we get 0 equals X squared minus 4. X squared equals 4, X equals plus or minus 2. That generates 2 points, the point 2, 0, and the point negative 2, 0. Okay, for the Y-intercept, we replace the X with 0. 0 squared minus 4 is negative 4. So Y gives you negative 4. And so your Y-intercept is the point 0, negative 4. On number 15, to find the X-intercept, we replace Y with 0. So we take the 3 on the other side. Absolute value of both sides gives us a plus or minus 3. So we have 3, 0, and negative 3, 0. For the Y-intercept, we replace X with 0. So you can see it here in the absolute values. So 3 minus 0 is 3. So we get the Y-intercept of 0, 3. On H of X, we replace the Y with 0. 2 equals X. In other words, we move the negative radical to the other side, and then square both sides, and we get X equals 4. So that gives us the X-intercept of 4, 0. On the X-intercept, you always have the X value, the Y value is 0. On the Y-intercept, you always have the Y value and the X value is 0. Okay, domain and range. Domain being the set of possible X values. So if we look at this, since this continues forever, both upwards and outwards, we've got negative to positive infinity. For the range, we always go low to high. So in this case, we begin at 2 inclusive and go to infinity. In this piecemeal item, our domain starts out here, comes to here. There's a gap in this line, but that gap is filled here, and then it continues forever, so negative to positive infinity. In the case of the range, we begin down here at negative 10, and that is inclusive. We continue upward, although there's a gap right here. the gap right here is filled by the y values over on the other right-hand side. So our range is inclusive -10 to infinity. Okay, number 19, another piecemeal graph. The horizontal line is represented, well, first let's do the domain. This continues forever. This included point takes care of that unincluded point, and this continues to x equals 4. So we've got -infinity to 4 inclusive for the domain. For the range, we've got all the values of 1 that are contained in this line that extends to the left. So the set of 1 values union with from 2 to 4, or 2 to 8 rather, excuse me, we're going up. Okay, on number 20, for the domain, we have a starting point here at -2. And in this case, this should be inclusive. This -2 should be inclusive. That should be a brackets, not a parentheses. Okay, and it continues in this direction forever. In the case of the range, these two are backwards. We go from low to high. Well, this goes to infinity. So the -infinity should have been first, followed by the 4 right here, inclusive. A mistake on the handout. Okay, I was able to change this one somewhat, but I was not able to fix that on a PDF. Okay, interpret a function graphically. In this case, what we are doing here is we are, with a substitution value of -3 for x, we are trying to find out the value of y. So we go to x equals -3, 1, 2, 3, and we go down and we see that y is -3. Here we have, for a substitution of x equals 0, we want to find y. So here we see that it meets here, so it's 2. For c, in this case, we are saying that y equals -1, or y equals -1, and we have to find out what x is. So we find out where y is equal to -1 right here, and we see what x is, and it has a value also of -1. For d, again, y equals 1. So we find where y is equal to 1. So this line right here, it's not included there, but it is included here. So in this case, where y equals 1, x then is equal to 2. The x-intercept, there is no x-intercept. The y-intercept is the point 0, 2. The domain of f, since this point covers that gap, this goes forever, is negative to positive infinity. The range, we go from negative infinity to -1, union with 1 to infinity. Okay, in this case, we're just finding the x and y intercepts. So in this case, to find the x-intercept, we replace y with 0. When we replace y with 0, we get 3x equals 6, x equals 2. So the point 2, 0, right here, the x-intercept. For the y-intercept, we replace x with 0. So we replace the x here with 0, wiping out that 3. So we get -2y equals 6, y equals -3, and the point 0, -3. We replace y with 0, so we get 5x equals -10. Divide both sides by 5, x equals -2. So the point -2, 0, right here. And in this case, this becomes a vertical line because there is no y component here. So there is no y-intercept because it's not on the y-axis itself. In this case, we have y equals 2. There is no x component. This is a horizontal line at y equals 2. The y-intercept is the point 0, 2. The x-intercept, there is none. Okay, we're going to have slope problems. Now, on your test Monday, there will not be a slope problem specifically like this. However, this will be a lesser included step in one of your problems where you have to use the point slope formula. So here, they're calling this point 1 and point 2. So we take the y value of 0.2 minus the y value of 0.1. Negative minus a negative gives you right here this 3. So we have -8 minus 3. I showed that wrong a moment ago. Now we move to the x values in the denominator. 1 minus -2. This simplifies to -11 over 3, which is your slope. Okay, in this case, the only difference is it's decimals. Okay, so we've got the 1.3 minus -0.4 over 0.8 minus 1.2. This gives us 1.7 over -0.4 equals -17/4. Okay, number 6, find the slope of a horizontal line, y equals 4. Well, that's simply the number, the line at y equals 4, a horizontal line. The slope of it is going to be 0. You could get 4 minus 4 over whatever x values you picked, which would still be equal to 0 over whatever. In the case of a vertical line, x equals -3. Your denominator will always become 0, which is undefined. Okay, we're going to change this standard form equation into y equal mx plus b so we can see what the slope and the y-intercept are. First thing we do, we move the x to the other side, divide every term by 3. So the slope is 2/3. The y-intercept is the point 0, -2. In this case, the x is isolated, but we want the y isolated. So what we're going to do then is we're going to move this 4 over with the x's, then divide everything by -2, giving us -1/2 x plus 2 equals y. In that case, the slope is -1/2. The y-intercept is the point 0.02. Here are the graphs of those two equations. You can see what from the y-intercept of 0, -2, up to over 3, and in this case, up 1 over 2, or down 1 over 2. The negative in front of the x dictates that this line must go downward left to right. Number 10, okay, here's the y equal mx plus b formula. It tells us we have a slope of 5, and it tells us we also have a point of -2, 3. You can solve this in this manner, or you can more efficiently solve it using the point slope formula, which is the way that I recommend. Okay, now we're actually dealing with the point slope formula. Y minus y1 equals m times x minus x1, x sub 1, I should say. So in this case, we put in the slope of 2 that it gives us in the problem here. And then y1 equals 2, x sub 1 equals -4, but we've got a minus a negative, so that becomes +4. We distribute this 2, and then we take this 2 to the other side. So that gives us 2x plus 10, y equal 2x plus 10. So here's the y-intercept. Then we go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and all the way down to here, at least past the x-axis. Okay, in this case, the slope is -2/3, and it passes through the point 50. We replace y with 0, we replace x with 5, we replace m with -2/3, which gives us y equals -2/3 x plus 10/3. This graph is drawn incorrectly. Unfortunately, I can't correct it with my pen on a PDF. So in this particular case, I don't know, maybe I can. Let me try something. Okay, in this case, now you can see the corrected line. I didn't move the points, but the y-intercept is 10/3 or 3 1/3, and it goes down 2, right 3, down 2, right 3, and so on. Okay, here we've got our 2 points, point 1 and point 2. You put in the 1 and the -4, which gives you +4. You put the -2 and the -1, which gives you +1. You simplify 5 over -1 equals -5, or -5/1. In this particular instance, then we use the point slope formula. We put in the 4. We're going to use the first point. Put in the -4 here. We put in the -1 here and the -5 there. We distribute the -5, take the 4 over to the other side, which gives us y equals -5x minus 9. And you can see the graph down in the lower corner here. In the case of number 4, it tells us it goes through the point 2,3 and the slope is undefined. If the slope is undefined, it's a vertical line. And here it tells you the x value is 2. So here is your vertical line at x equals 2. Okay, slope of parallel and perpendicular lines. Okay, the slope of a parallel lines are the same. The slope of perpendicular lines are negative reciprocals. So in this case, if the slope of the original was -3/8 for parallel, it'll be -3/8. For perpendicular, it'll be +8/3. If the slope original was 20, it would be 20 for parallel lines and -1/20 for perpendicular. If the slope is 0, parallel would still be 0, but perpendicular would be undefined because 1/0 is undefined. The equation that passes through the point -1, 2 and parallel to this line. First thing we want to do is put this in y-intercept form. So we take this -3x over to the other side. We see that our y-intercept is 4. We see that our slope is 3/1. So we take this slope of 3 and the point -1, 2, substitute it into the point slope formula, take the -2 to the other side, and we get y equals 3x plus 5. Okay, we're going through the 0.68 and it's got to be perpendicular to this line. So first thing we do is put this line in point slope form. Take the 5x over to the other side. divide every term by 2. 10 divided by 2 is 5. Okay, so our slope is negative 5/2 on the original. So our new slope will be positive 2/5, the opposite reciprocal. So we use the point slope formula. We substitute the 8, we substitute the 6, we substitute the 2/5. We distribute, take the 8 over to the other side. This 8 we have to convert to 40/5, so we can add the negative 12/5 and the positive 40/5 to get positive 28/5. Hardware store charges $28 to rent a carpet machine for 24 hours, $10.98 a bottle of shampoo. Write the function that represents the cost of renting the machine for we don't know how many days, along with 2 bottles of shampoo. So the cost is 28 times the number of days plus 2 times the cost per bottle of shampoo. A little bit of simplification, 28x plus 21.96 or $21.96. The follow-on equation is what if it's 2 days? So then we replace the x with 2. 28 times 2 is 56, plus 21.96 gives you $77.96 for 2 days rental and 2 bottles of shampoo. Transformation of graphs. Okay, I've shown you these a number of times, at least 4 times the other day, where you have just a linear equation. This one is y equals a number, in other words, a horizontal line. Y equals x, the identity equation where it's over 1 up 1 over 1 up 1. Absolute value of x starting at the origin at 45-degree angles. The basic x square function, which is the parabola with vertex at 0, 0. Cubic function goes low to high, left to right. In this case, it passes through 0 because you've got plus 0 hidden out here for your y-intercept. Square root of x. This one is going to be the reciprocal of that one. If you take this one, turn it 45 degrees or 90 degrees rather, you would have this shape. But we can't have the bottom of the graph because that would involve negative x's, which would be imaginary numbers. The cube root function is the reciprocal of the cubed function. In other words, this one just at 90 degrees, rotated 90 degrees. And then the 1 over x function, again, these approach x equals 0, but they will never touch it. That's because you can't have a 0 in the denominator if x is 0. This is called an asymptote, a no man's land, like the junkyard dog and an electronic fence. Vertical and horizontal translations, I'll let you read that. Inside, opposite direction. Inside, again, opposite of direction. Now, in these problems, they're going to ask you to fill out these point values. I don't care if you fill them out or not. if you understand that the square root of x function is this black line, and that you're just going to move that black line up 2 spaces everywhere, and then draw the new line, as far as I'm concerned, that's good enough. Likewise, on this one, this is inside, but if you understand the square root of function is, again, the black line, and that this is going to move everything 2 spaces to the left, 1, 2, 1, 2, 1, 2, and so on, then that's going to be good enough. I'd prefer that you label these graphs as if you do that. Now, my motto is work smarter, not harder for Carter. So if you can do it this way without having to plot those points and use your calculator, then you're way ahead. Here's 2 more the same way. Okay, you've got this one. You've got -2 added externally, so it's going to shift the parabola, the black parabola, down 2 spaces. In this case, it's inside, and it's a minus, so it's going to shift it right, opposite of sign, 2 places. So here's my basic, and it shifts it 1, 2 places to the right. This one has 2 transformations. You always work from the inside out. This +1 shows that we're going to shift everything 1 place to the left. So we would take this black y = x² graph, move it 1 place to the left, and then we would take this vertex that's 1 place to the left and move it down 4 places. And then we would have our graph. Okay, this is an absolute value, the characteristic V. We're going to shift the black V 2 places to the right and up 3. 1, 2, up 1, 2, 3, and then draw it. Horizontal shrinking and stretching. Okay. Y = f of x. Okay, so if a is a positive number greater than 1, then a times f of x is the graph of f of x stretched vertically. In other words, it's going to make it taller. If it's a fraction, then it will make it shorter. Now, horizontal. If it's a positive number, then it's going to make it shrink horizontally, become narrower. If it's a fraction, it's going to make it spread out wider. Now, these are kind of reciprocal things, okay? In this case, if you use a positive number for vertical, comparing vertically, it makes it taller. For horizontal, it makes it shorter. A fraction, for vertical, it makes it shorter. For horizontal, it makes it wider. Let's look at this. We got a fraction. Okay, in this case, the green line is y = x². So we're going to take that times 1/4, and it's going to spread it out. Now, what does this do? Vertically, it's not as steep as it used to be. Horizontally, it's stretched more than it used to be horizontally. Okay, now this one, we got a whole number times it. Vertically, it's going to make it taller. Horizontally, it's going to make it narrower or shrink it. Okay, square root of x. Square root of x is this green graph. If we take a 5 times that, it's going to make it taller. If we take a 1/5 times that, it's going to make it shorter. Now, this is the point at where we stopped in class this morning, so I'll stop right here. I want to remind you that we have the in-person test tomorrow. Tomorrow we'll finish grading these handouts, and then you'll submit those tomorrow night through Blackboard in PDF form. Once again, the test on Monday will be in person. You can come in at 10 minutes after 11 and get an extra 20 minutes of time to work on it if you wish. The test has to end promptly at 12:20 because there's another class coming in. So this is where we'll take up tomorrow with the lesson. If there aren't any questions, then at this point, we will just end the class.